Okay, so the whole goal of this is to try to figure out what a function is. So the big part of the function is that the domain can only be attached to one element of the range. Okay. So we should see the domain, which are our x values, only ever connect with one y value. So let's do some just quick ones to look at to see if we can differentiate first. So in this the first one, our domain and our range are as follows. So 3 is an element of the domain, but it's attached to multiple values of the range. Same with 5. So this one would not be a function. This one down here, again, our domain are x values. So you have 1, 3, 5, and 7. So first of all, none of those are ever repeated, which means they cannot be attached to multiple values of the range. So this is a function. In this case here, if we just pull out a couple points, so maybe this one here, which is the point 3, 4, and this one here, which I'm going to say is the point 3, negative 4, you can see that the x value repeats and it's attaching to two different values from the range, or two different y values. So this is not a function. We also discovered that you can do this by drawing vertical lines. Okay? And if your vertical line passes through the graph more than once, it's automatically not a function. Then last up here, let's look at all of our x values. Again, none of our x values repeat, so no elements from the domain repeat. So there is no way that it could not be a function. So in the following, let's start off. For both of these, let's identify identify if it's a function or not, and then identify the domain and range. So in the first problem here, again, we're going to look at all the x values. And I do see that 6 repeats twice, and 6 attaches to two different range values, or two different y values. So this is not a function. And then for B, each of the elements of the domain is only attaching to one element of the range. Even though the range has multiple arrows to it, that doesn't matter. We're looking strictly at the domain. So this is a function. Okay. So for A, if I want to identify the domain and the range of those, that's going to be listing out all the values of the domain, so all the x values. So we have 4, 6, 6 is repeated again, 8 and 9. And the range would be 2 repeated again, 3. So those are all the numbers that we see. You don't need to write them out multiple times, because if you've included it in the range, that just identifies that that is one of the values that you will find in the domain and range. Okay. So for the domain of this arrow diagram, we would write these months. So January, February, March, and April. Okay. And then for the range, we would write the dates. So 28th, 30th, and 31st. And then the last problem here, so what happens if we're looking at a situation? So here we have a number of tickets and their cost. So is this a function? Yes, because all the elements of the domain are attached to only one element of the range. So function. And the reason being, domain does not repeat. Okay. And then we need to work on identifying the independent and the dependent variables. So when we're talking about independent, we're talking about something that does not change depending on something else. Okay? When we're talking about dependent, we're saying this is going to change depending on the other value that's given. Okay? So in this case, the number of tickets is just increasing. It's not being influenced by the cost. So the number of tickets, N, is the independent variable. But the cost, C, is going to change depending on the amount of tickets that are sold. Okay? And then to identify the domain and range, we need to remember that domain just means our independent variable. When we put domain, independent variable, and x together, those all are synonymous. So that's our number of tickets. So we'd have 1, 2, 3, 4, and 5 are in the domain. In the range, all of the money values.